Hi, we're going to talk about another pair of very common and very useful higher order functions. They're map and reduce. To motivate for the topic, we make the observation that lots of the code we write follows a particular pattern. So first is that given a list, we iterate over all the elements in a list, potentially transforming each one of them. And then secondly, after the iteration, we produce some sort of final result from all these potentially transformed elements. So for example, here is a code snippet that given a list of numbers, it would um, it would take the square of each of the elements in that list, and then it will sum up all the squares of the elements in the list. So the second example here is again given a list of numbers. Now it doesn't quite transform each of the elements. However, it does produce one final output that is the smallest element in the given list. And there are many, many other examples that are similar, or code that is similar to these two that I've shown here. So as it turns out, there is a general framework to perform such task, and this framework or the idea is called MapReduce. And surprise, surprise, it kind of involves two higher order functions they call map and reduce. So let's look at the map function first. So the map function usually takes two parameters, could be more, but so the first parameter is a function, and this function takes one input and produces one output. Okay, and the second parameter is usually what's called an iterable. Uh, so an iterable is anything that can be iterated over, such as a list, a tuple, and a string. So let's, for the sake of our discussion, we'll say this is a list. Okay, so the map function takes these two parameters and then it applies the function to each element of the list. So, or another way to see it is, each element of the list acts as an input to the function, and the function will produce one output for each element, for each input element, and it will put all of these outputs into another list. So basically, the map function will produce an output list that has the same number of elements as the input list, which with each element transformed by the function. And now let's take a look at one of the example of how we can use map. So for example, if we have a list of all numbers from 0 through 9, and we want to triple each of the elements and put them in a new list. So we can write a for loop that does that. That's something that we've been doing. Or another way is actually to use map, right? To use map, we can basically just say map. So the first parameter is a function. So I'm going to use lambda here. It takes one input, it produces one output. I'm going to triple the input, x, and then I'm going to apply it to the list of, list. Okay, so let me run that. And well, here's the fun thing about map. Map itself doesn't, at least the Python's built-in map, it itself doesn't actually uh, perform the action or applies the function until you actually turn the result into a list. So there. So both of the for loop as well as the map uh, give, gives us exactly the same result, which is doubling the numbers 0 through 9, or sorry, tripling each of those numbers. Now, if you look at this and think, well, it seems like there is another way to do this in Python, right? And you are right. It is list comprehension can achieve the same thing, at least in the case for map. Anyway, so that's for map. Map is relatively straightforward. Reduce, however, is a little more interesting. So what reduce is, it also takes two parameters usually. One is a function again, and the second one is a list or an iterable. Now, the function that reduce takes is different from the function that map takes. So this function, it would take two inputs and produce one output. And map would apply this function kind of iteratively to all the elements in the list. And eventually that would result in a single output for the whole list, regardless of how many elements are there in the list. So let's actually go through to see how it works given a input list of here 4 elements. So what reduce does is that it takes the first 2 elements, feed them into function. Now function does whatever it does and produces one output. Okay, so there will be one output here, and what reduce does next is that it takes the next element from the list, and together with the output from the previous call to function, it now has 2 inputs, and then it feeds them again into the function, okay, which now then would yield one output, and it repeats the same process. It will take that one output as one of the input into the next call to the function, and the other input would come from the list. So, and finally, we are done here with the list having just 4 elements. We will end up with one result. So this is how the function reduce get its name, right? It basically reduces an input iterable that has potentially many elements into one final result. Now let's see how we can use the reduce function. So the first example we're going to look at is how to use reduce to sum up a list. So let me try to walk you through this. And so the first parameter to reduce is a function that takes 2 inputs. So I'm going to write a lambda function that takes 2 inputs. Now what we want to do with these 2 inputs, let's say 1 and 2 here, right? We want to add them up so that eventually we can add all of them up. So the result of the lambda function is just a plus b, and I'm going to apply it to the list iterable. And now let me run this, and hopefully we get 10, yes, which is the sum of 1 plus 2 plus 3 plus 4. Now, if you want to see how it works pictorially, then here is how we can see it. So remember, the lambda function, right, is the function that kind of adds its 2 inputs, a plus b. So reduce, apply the lambda function to the first 2 elements. So 1 plus 2, that gives us an output of 3. And then it takes this output of 3 and as one of the input into the next call to this lambda function. The other input comes from the next element in the list, which is 3. So 3 plus 3, that gets a 6. So 6 again is an input into the same lambda function again. The other input comes from the next element in the list, which is 4. So 6 plus 4, and that gets us 10. And we are done with all the elements in the list. And that's how we use reduce to sum up all the elements in a list into a single result. And yes, I want to mention that unlike map, which is a built-in function, reduce is not a built-in function. So, but it is part of a standard Python installation. So in order to use it, we just have to import it from func tools. And if we go the old-fashioned way with the for loop, this is how we would do the sum, right? So this is interesting or different ways of achieving the same results. Now, next, I would actually like you to give this a try yourself. Can you use reduce to find the smallest element of a given list? So in other words, here's a list, and then we do reduce lambda a and b, remember, always in a function that takes two inputs. What can we put here such that when this is said and done, we are going to get the smallest element, which in this case is 1. So pause the video, please, and give this a try. All right, let's go through this together. So we have to write a function that takes two inputs, and our ultimate goal is to find the smallest from the list. So between these two inputs, we should just return the smaller of the two, right? So we can return A if A is smaller than B, else we just return B. And we are going to apply this thing to the iterable or list of numbers. So let's hope it works, and it does. And if you want to see how it works step by step, here is how it does that. So the first thing it does is it looks at the first two inputs, and it returns this function, this lambda function returns the smaller of the two. So between 2 and 9, it returns 2. Right? And then it takes the next element from the list, and that gets fed into the same lambda function here. So between 2 and 1, the smaller of the two is a 1. And then again, 1 and the next element from the list, 3, gets fed into the lambda function, and out comes the smaller of the two, which is 1. So we have a final result of 1, which is the smallest of the list. And we can compare this approach using reduce with the old-fashioned approach of using a for loop. And I personally actually do prefer using reduce because I don't have to keep a state variable, the smallest so far. I don't have to remember to initialize it and compare it and then change it and all that. So this is a different and potentially better way of looking for the smallest element in a list. Now, there are a few corner cases for reduce that we should take a closer look at. So the first one is, what if the list is empty, right? What happens? So let's take it out and see. When we run it, we actually see a exception being raised. It complains that reduce of an empty sequence with no initial value. Okay, so let's take a step back and think about this. We're trying to figure out the sum of a list of numbers. Now, if the list of numbers is empty, then it's reasonable to say then the sum is 0, right? So in order to tell reduce to return 0, if the list is empty, we can give it an initial value, which is a third parameter to reduce. So this is a value that reduce would return if the list is empty. So let's run that, and now it says 0. So that's reasonable. Now, what about the other case where we look for the minimum element in the list? What if the list is empty? Well, if we run this, as we expect, the same exception is raised. Now, what should we do in this case? Let's think about it. The list is empty, so it really doesn't make sense to look for the smallest element in a list that has no element. So in that case, I mean, I would leave the exception the way it is, so that if somehow we do try to look up the smallest element of an empty list, we get an exception, so that we have to we know that we are doing something that's not quite sensible. Now, there is another corner case, and that is if the list has just a single element, right? Because remember, the function that it takes is always a function that takes two inputs. So what happens if there's only one? What is it going to do? Well, let's run it. And in this case, I mean, it returns 3, and we think about it, we're looking for the smallest element in a list that has a single element. Well, that single element is the smallest element. So it returns that element. So as it turns out, the reducer is actually smart enough to recognize this scenario, that if there's only a single element, then it will just return that instead of trying to apply a function that requires two inputs, which it's not going to work, right? So it's good that it knows how to handle the case of a single element. So what about in our other example of summing up all the elements in the list? So if that list has just a single element and we have an initial value, what does it do? Well, when we run it, it seems to just return that single element in the list, as it does in the example of finding the minimum or the smallest element. Now, does it always do that, right? Is it the only thing it does? Well, let's actually try to change the initial value here and see what happens. So when we run it, it actually returns 11 instead of always the first element. So what happens in this case with an initial value as well as at least one element is that now reduce has enough values to apply the function, right? Because now it has at least two inputs. So it would first apply the function to the initial value and the first element. So in this case, it's the initial value is 10, and then plus the first element, which is 1. That's how it gets 11. And it will continue to do that if there are more than one element. So for example, if we put another 2 here, then it will add the initial value plus all the elements in the list here, which yields 13. So if you want to look kind of pictorially, what happened here is that the initial value plus the first element is fed into the lambda function, and their output 11 is then again fed into the supply function again with the next element in the list. So that's a kind of a brief introduction to MapReduce. So Python's particular implementation of the map function and the reduce function is actually one of the simpler implementation of the kind of the idea of MapReduce. Now, MapReduce, as we said earlier, is a general framework for solving a class of problems, and it can actually be extended to help solve much bigger problems that involves a ton of data in a distributed parallel fashion. So it's a really cool idea, and here is a link to the Wikipedia article with a lot more details if you are interested.